I'm an arable rep down in South Canterbury as well as extension agronomist in the cereal space. Real amount of passion in the herbicide resistance area. So it's really great to see a good turnout here. The value that hopefully we all get, and we will all get tonight from Peter's presentation, it's great for our industry, what we've got here. So PGG Wrightson Seeds, PGG Wrightson and Bayer have obviously funded Pete over here for the week. So we all see the value in this for our industry. Obviously, a lot of you understand the potential risk with herbicide resistance, and we'll probably understand it a whole lot more by the end of Peter's discussion tonight. So yesterday, I just want to go over quickly, we had a day out with Peter yesterday and visited a couple of farms around South Canterbury that have been facing this issue for years, and I just wanted to share with you a couple of take-homes that we got out of that. So the key thing I got was when the farmers owned it, it wasn't anyone else's fault. No one else was to blame. The farmers then sort of took the ownership of the problem. They understood where their issues were, what the problem was, and they managed the problem. They worked alongside their agronomists and got really good results. That's where we're getting success in this. And it's not blaming chemicals not working, things like that. It's right, what didn't work last year? What can we do next year to do it better? These farmers also, their decision making was really direct. Like there was lines in the sand. They made decisions early, and that was pretty cutthroat in terms of that. And they've made so much progress because of that. They understand the benefits of reducing the weed seed drop. So prior to harvest, the roguing, they understand how important that is in terms of achieving really good results. But the whole farm system, that's what they're really working on, and that's what's really getting them results. Understanding how it fits in, how different little tweaks they can make within their rotation, the headers, different things that they can make to reduce the seeding the following year, to increase the efficacy of the chemical, all of that sort of thing. It's that, and understanding their farm system and how herbicide resistance fits into that, that's where they're making really good ground. So I see Mid-Canterbury up here. We're not in the same situation as South Canterbury or Australia. We have a really good opportunity to get on top of this before it's a big issue. So one of the questions one of the growers last night asked, he said, if we knew what we knew now, would we be, like years ago when we first saw the first resistant grass, would we be in the same position that we're in today with battling these huge numbers? And obviously Peter answered that question, but he was referring to it in terms of nature and environment, things like that. But the reality is we know so much now that we can stop it getting to being the big issue that we've got in other areas. So I see Mid-Canterbury as a really good opportunity to jump on this and stop it becoming a big problem.
Really looking forward to tonight. And as I think Alice has said most of what needs to be said. I hope you all sort of can take something away. I think from an ag chem company, it takes a lot of time and costs a lot of money to bring new products to market, and certainly the rate of resistance is a lot faster than that. So I think there's some real important steps we need to do to make use of the tools we've got and keep them working for as long as possible. I think we're a little bit further down the road than Australia in terms of the resistance development, and I think we can really take some lessons out of that too. And I'd just like to, once again acknowledge the combined sort of effort of PGW Seeds and Bayer for putting on these evenings and sharing that knowledge. But it won't hold it up any longer. Peter will tell you a little bit more about what he does, and we'll let the night get underway. So thank you.
Thanks, Jono. If I'd known it would be filmed, my hair is a bit messy because I was wearing a beanie today. So good evening, everyone. I'd like to go through what I do and what's happening in Australia with respect to herbicide resistance, and also how we manage the problem. No farmers have stopped farming because of herbicide resistance. Some guys have got a lot of resistance, but they are managing and they are profitable. So there are tools there, but raising awareness and preventing major issues can make things a lot cheaper to control weeds in the future. So I wear two hats. I wear an Adelaide University hat. So I've been employed by the University of Adelaide for 20 years. I actually graduated from there many years ago, but went overseas and worked overseas on herbicides and resistance. Came back to Australia. They've been working at Adelaide University since 2005. So I'm from Adelaide. And there's a team of people there, and we do everything from looking at the field level, how herbicides work under different conditions, to resistance in the field, to pot trials to try and understand conditions under controlled environments, to the enzyme level, to the gene level, trying to understand the whole package. But the whole aim of this is to actually work out strategies to manage resistance and use herbicides to the best of their ability, because you don't just put a herbicide in a tank and spray it. There are conditions that you can, if you're aware, can make that herbicide work a lot better, be it a post-emergent herbicide such as glyphosate or a pre-emergent herbicide such as Sakura. They don't work under all conditions. Secondly, the second hat I wear is I have run my own business, Good Plant Science Consulting, and I'll go through that a bit later on. I conduct commercial herbicide resistance testing for farmers. The farmers will send me their seeds or their plants. We will do a resistance test in pots, growing plants, spraying under field conditions, obtaining the results, feeding back to their agronomist or directly to the grower. Then they can manage more accurately what herbicides are going to work, what herbicides don't work, therefore determine their cropping rotations that way. So having this information, this tool, creating a baseline of the herbicides that work in your field is a very important piece of information, because it allows you to make educated decisions. Using, for example, Gallant on ryegrass that's 100% resistant, it's a waste of time. You're going to pay money for the herbicide, you're going to waste your time cropping, you have crop competition, you have resistant seeds falling back into the seed bank and creating problems for the next few years. So a simple test allows you to avoid such no-brainer type situations. And we use a couple of tests there. No problem. So yeah, thanks to PGG Wrightsons and PGG Wrightson Seeds and Bayer for providing the opportunity to cross the Tasman and present this information. It's been I've learned a lot more than probably you guys will learn, because every day there's so many different things in a new country. So let's set some standards here. What is herbicide resistance? Herbicide resistance is the evolved ability of a species to survive a field rate of a herbicide that would normally control that individual or that population. So on the top here we have a very weak laser. You guys have it's very weak. That's okay. So the top row there is one population from one paddock. The bottom is another population from another paddock. So on the left-hand side here, we've got untreated, then increasing rate of glyphosate. You can see the top row is surviving increasing rates of glyphosate. There's more and more damage, but it is nevertheless surviving. So that is resistant compared to the bottom population, which is susceptible, has been killed even with the lowest rate of glyphosate there. So that is a resistant population. And the seed from that resistant population will also be resistant next year and possibly be more resistant, survive higher rates of herbicide. On the bottom, there's a snippet there from a field. There is dead brome grass there, and there's live brome grass. that live brome grass has germinated after the herbicide was applied. So the older plants got the herbicide, they died, then there was a subsequent germination. They've survived, they haven't been exposed to a herbicide, they're not resistant. That's just dormancy and weed dynamics. So this is a update of a table. There's a website which provides, scientists put in their new cases of resistance that's scrutinised by this, actually an Aussie guy, Ian Heap. And we have here on this actual column here, the unique cases of weed resistance in each country. US is number one. They have 132 unique cases of resistance. So a case is, for example, we've got ryegrass resistant to gallant only. That is one unique case. Another case might be ryegrass resistant to, say, Hussar. That's another case. Another one might be ryegrass resistant to gallant and Hussar. We've got two different resistance to different modes of action. That's another one. Or amaranthus or fat hen resistant to atrazine. That's another case. So that's how it's explained. Good old Australia's number two, and New Zealand's 22 unique cases of resistance to several species of weeds. Yeah, so quite a few of the most common ones here. You can see the modes of action. That's the old numbering. So these are all the grass killers or the group 1 herbicides, such as galant or clethodim. And the next ones are the group 2 herbicides or herbicides such as Herbicide, Rexade, or Glean. There's 5 unique species there, and a few more to the other modes of action. So these are all the species that have been documented from New Zealand to be resistant. They're in they're in corn and pastures and golf courses, potatoes, pastures, grapes. On Monday I was speaking to grape growers, and in arable cropping, the main one by far is lolium. We've got multiflorum and perennial. We've got another species of ryegrass, but ryegrass is ryegrass. They're all very similar. And we've got resistance to quite a few modes of action. You've got resistance to gallant, to Twinax, glyphosate, Hussar, lots of other group 2 herbicides, Rexade as well. So they're the ones that have been confirmed. Okay. We've had no-till in the country for about 20, 25 years, but before then we were relying predominantly on tillage to control weeds in summer. And when you have huge dust storms, as occurred, there was drought in 1983, yeah, there's huge dust storms here, in this case covering the city of Melbourne. So it looks like something from that movie, The Mummy, big dust storms occurring. So this is not sustainable. We're losing valuable topsoil, and it's just no right. So what's happened since then is we've entered a period where we are virtually not disturbing a significant proportion of the field. It's staying the same, no disturbance at all, except when we sow, we disturb a small proportion of it. One of the reasons is because of the advent of this herbicide, Roundup, glyphosate. That allowed us to control weeds in summer without the need for tillage. So suddenly the soil formed a crust, we had retained stubble, water infiltrated, weeds were controlled, water was harvested, nutrition was harvested, and so during the autumn period where crops were sown, once those roots found that stored water, even if there were droughts, the growers got a good return. So suddenly, where in the past droughts meant severe bad luck, not today. Farmers make huge profits even during a drought if there's summer rainfall and there is stored moisture. But controlling weeds in the crop was very difficult. Then came what I call the golden years of weed control, where herbicides like Herbicide or Galantas are the same mode of action, Glean, Logran, and Hussar later on, these herbicides allowed us to control ryegrass in wheat crops, okay, for the first time ever. So what did that mean? Farming's easy. Let's just spray these herbicides, shut the gate, go on holiday, come back in December, harvest the crop, make money, go on holiday again. And that's what they did for about 5-10 years until one control measure, ryegrass said, yeah, right, as if you're gonna kill us. So that ryegrass resistance started multiplying more and more, getting more and more complex, until we've got huge resistance to group 1 herbicides and group 2 herbicides. So to your gleans, your hussars, your twin axes, those herbicides. So today, without having multiple strategies in the same season, like at least 3, you have a significant weed infestation. So currently, this is what growers are doing. GPS guidance, stubble retention, moisture conservation. So they're sowing in laser level lines. 22 centimetres is quite a common distance. Right, so the stubble is last year's crop, and then 2 years later, that stubble has decomposed, and they'll sow the crop in the same location exactly where the crop was 2 years ago. So root channels have rotted from previously. There's nice long root channels. Earthworms are in there. The new seedling, the roots just follow the root channels. Less energy required. Can burrow in deeper, find stored moisture, and so it's a very sustainable system. Seeds, the weed seeds also remain on the surface because you're not burying the seeds. You're not disturbing the seeds. The seeds are on the surface. Up to 50% of the seeds that are shed from a ryegrass plant have decomposed by the following season. So that is one measure that's actually working. If you're not burying them, soil is a very good inhibitor, a very good insulator of seeds. So if they're on the surface, they're more prone to degradation by insects, by ants, by fungi, by false starts with a bit of moisture and then wetting, drying over summer, and so that can remove up to 50% of that seed. The key is pre-emergent herbicides. When they're applied in very close contact with the seed, and we're getting excellent herbicide to seed contact, which means a good kill. But resistance can happen quicker because you're exposing the entire seed bank to herbicides, and so if there's any resistant ones, they survive, any susceptibles are killed. You're not bearing any susceptibles at depth to actually buffer that. Pre-emergent herbicides, whereas if you're burying the seeds deeper, then there are cases where the herbicide is quite distant from the seed, and therefore you have less effect on those deeply buried seeds. So we're now relying more reliance on, this should be pre-emergent herbicides or herbicides applied soon after emergence, early post-emergent herbicides. So this system here is sustainable, even with multiple resistance to many modes of action. So one of the funding bodies, our equivalent of our GRDC's equivalent of FAR here, funds us to conduct random weed surveys throughout Australia every 4 or 5 years. So basically what we do, we go into 200 fields in every state, so 1,500 across the country. Initially we used to just trespass, but biosecurity, we're not allowed to do that anymore. So we actually ask farmers before, which adds a bit of, so that's a lot better now. Collect various weeds. There's about 6 species we collect, take them back to the lab, clean them over summer, allow dormancy to break because seeds won't germinate during summer because they know it's the wrong season to germinate. In winter, we'll do pot trials, obtain the results, feed that back to agronomists and farmers and the chemical companies. And that's one way where chemical companies are aware of the issues of resistance, and that helps them then fund new projects to identify new herbicides. So this graph here, every single circle there is, and the circles up here too, a field where we collected ryegrass and other weeds from. The blue are fields where we found resistance. Sorry, where we found ryegrass, not resistant ryegrass. And up here, there's a lot of open circles. You may not see them very clearly. That is central New South Wales, southern Queensland. Ryegrass is not very common there. It's mostly black oats or wild oats there. So the other thing is that even though there's a lot of ryegrass there, in most cases, most of those fields we went to were pretty clean. It was often very hard to find enough ryegrass for a handful of tillers, of seed heads. So growers are doing a good job. So we're testing what's left at the end of the season. They could be the ones that are extra resistant or germinated later when the pre-emergent herbicides had finished and they were germinating later in the season. So, and in like 20% of cases, we didn't find any ryegrass in a 2 hectare part of the paddock. So it was really rare to find fields full of resistant ryegrass or full of ryegrass. So something's definitely working there. So these are the results of many years from basically the 2000s to current times, 20, 30, 25 years later. This is South Australia, but other parts of Australia are very similar. So I'll explain this table. This number here represents the percentage of fields that contained resistant ryegrass. Resistant ryegrass is defined as a sample where we tested in pots the following season that survived 20% or greater. So if a sample had 19% survival, we didn't include it as a resistant here. It had to have 20% survival or greater. So before the year 2000, 38% of our ryegrass was resistant to things like Gallant or Twinax. Really high, 38%. Currently in New Zealand, it's lower than that. We were there before the year 2000. Sulfonyl ureas, back there we had Glean, 22%, and Troflora, 9%. You can see over the years how the resistance to the group 1 herbicides, the FOPs, has increased. And in some areas, such in Western Australia, this number is around 90%. So it's much higher in certain other states. The DIMs, here we're talking about clethodim. We weren't testing it initially, but it's increasing there, but it's still quite low compared to FOPs. Both of these herbicides kill exactly the same way, but there are some subtle differences. And you can see that there are cases where you can have resistance to a FOP, to Gallant, to Twinax, but clethodim still kills that ryegrass. And that's where the power of resistance testing is, because you can identify those subtleties in a particular field sample. Glyphosate, in the early days, there was zero detection. And over time, it's been increasing at a very scary rate. And the glyphosate resistance is increasing much faster than clethodim. And in the next survey, which we're starting this year, I'm very sure that'll be higher. Sulfonyl ureas, well, basically started from low levels and are now 85% resistant. In Western Australia, the survey from Western Australia, 99% of the ryegrass was resistant to Glean, to Hussar, to Rexade. 99, every single sample collected at random is resistant. So these herbicides are lost forever to ryegrass. So that's how bad it doesn't get any worse than that. Troflora increased to 1 in 2 paddocks, but because of the availability of new pre-emergent herbicides that control resistant to these guys, the resistance is now starting to fall in South Australia. South Australia has the highest levels of Troflora resistance, or Treflan, in the state. This is Treflan, sorry. And Sakura, we've only just started in the mid to late 2014s, and you can see it's basically zero. These are thousands of samples we've collected. So that's a snapshot of what our growers are dealing with today. This is a trial I did for Bayer. This is some ryegrass originating from this area that was sent to Australia. Our quarantined guys didn't like it, sent it back to New Zealand. They checked it up, they sent it back to Australia, and finally we got it after about 3 months. So we got 6 low-layer multiflorum samples, and number 7 is a perennial ryegrass. With every resistance test we do, we include a known susceptible that's killed with Hussar, Twin-X, clethodim, and glyphosate, Roundup, and one of our known resistant ones, which we know has resistance to Hussar, Twin-X, a little bit of resistance to clethodim, and also glyphosate. So they're our standards. So we know if the herbicide, the test is working correctly, and these are the new samples that we hadn't tested before. So population number 1, 100% of the seed we tested, the plants, were resistant to Hussar and Twin-X and clethodim. This is very surprising. It's very rare to get really high levels of resistance to clethodim, and glyphosate too, 60%. So this grower here has some serious issues. So if he's using these herbicides with blind, not knowing that he's got that resistance, then there's going to be some pretty large failures. Number 2, resistance to Twin-X and Hussar only, not to the other 2. Population number 3 was susceptible to everything, 0% survival. Number 4, we had resistance to everything, but less so than population number 1. Number 5 was only resistant to Twin-X, 95%. So virtually all of the plants were resistant. Number 6, we had intermediate. Number 7 too, some little bit of glyphosate resistance occurring there too. So this kind of result indicates, okay, we've got glyphosate resistance, we've got to be careful now. We don't use glyphosate, but we have to be aware that if we spray glyphosate and we have some survivors, maybe we should do something about them so they don't set seed and increase that resistance further, because this population here is a lot further. Yes? Yeah, that's a good point. So this actually is a pretty high rate for pot trials, because we've got plants growing under perfect conditions, applied perfectly with a sprayer, 100 litres of water, just optimum. So these rates will probably increase. If you increase it by 50%, that would probably be the equivalent field rate of activity in the field under good conditions. But yeah, that is for you guys. That is a low rate, but you can see what it does on most of the other populations. That rate is killing them. If we increase this rate further, we will definitely get more damage on that one. It would be 40, 30%. Maybe if we went to 4 litres, we may kill it completely. We may have 5%. We don't know. And in some of the farmer testing we do, we actually do test 3 or 4 rates of glyphosate, and we can actually see how that responds as you increase the rate. So I'll spend some time discussing pre-emergent herbicides, because pre-emergent herbicides have very different modes of action to the group 1s and 2s, so to your Twin-X's and your Hussars. And they have multiple modes of action, so they kill weeds by targeting many different systems, not just one system. And another critical importance is that the pre-emergent herbicides reduce the amount of seed and plants exposed to your in-crop post-emergent herbicides. So instead of exposing 500 seedlings per square metre to Twin-X, you're exposing 20. And so the chances that there is a resistant individual in those 20 is less than in 500 plants. So this is layer number 1. Then layer number 2 are the post-emergent herbicides. This is a series of, these are field trials, not pot trials. So these were done in the field. It's about a summary of 8 or 9 trials done in southern Victoria. Southern Victoria is a high rainfall zone, lots of ryegrass, big problems, lots of resistance. So these guys here, they're trying some pre-emergent herbicides, try and see how good they are on samples that are resistant to group 1 and 2 herbicides. So in this area here, Twin X resistance would be around 85–90%, and Hussar and Rexaid not too much further behind that. So with just straight Treflan, we're getting the trials indicated between 20 and 80% control. Or actually, the data there is the reduction in the number of ryegrass spikes or seed heads at the end of the season as a percent. Avidex, better, between 90 and 50% reduction. Boxer Gold is a, you guys know Boxer Gold? Boxer Gold is a different chemical from Syngenta. It's a mixture of a product called Prosulfocarb. We use this in potatoes, Prosulfocarb, and metolachlor. It's a product used in potatoes. Boxer Gold, a bit better than Avidex. Sakura alone, we're getting between sort of 75 to 95% control. One application, that's all. At the end of the season, that's what was left. So this is only one treatment. Normally, growers wouldn't do this. They would actually apply 2 or 3. But this is just to see what the effect of one pre-emergent herbicide would have in that crop. Then we have some tank mixes, and Troflora and Avidex, pretty average. These we don't really use. Sakura plus Avidex is a very important one for us, and we are getting, pretty high levels between not 85 to 95% reduction in ryegrass seed heads in all of the trials. So the smaller the bar, the tighter, the better the control is over all of those field trials. And I won't go through all of them, but the other one that is really very effective strategy is using Sakura pre-emergent and then Boxer Gold post-emergent. So we've got a pre-emergent reduction, and then 4 weeks later, Boxer Gold on 1 to 3 leaf seedlings. You get about 10 mils rainfall, washes it into the root zone, activates the herbicide, kills that later germinating ryegrass. So that one is giving us around high 90% control in every one of those 9 to 10 trials. So this is very, very common. Now we have some more because we have some different pre-emergent herbicides also. So using a single active ingredient, which was very, very common in Australia a decade ago, that's what we were achieving. Now we're achieving a lot better control. So the strategies that these guys use, group 1 and 2 herbicides, not working all the time. As I'll show you, resistance testing can actually tease out where there are opportunities to use those herbicides. We rely on diverse mode of action herbicides, so those pre-emergent ones, or mixtures, or early post-emergent like Boxer Gold, or another one which is coming soon from Bayer's Matino Complete. In summer, we'll kill ryegrass with glyphosate or paraquat, or mixtures with some other herbicides, group 14 herbicides, in the same family as Sharpen, but slightly different. Seed set control, so hay, silage, crop topping, spray topping, glyphosate, paraquat. These are some other strategies that growers will use towards the end of the season. Seed capture, then we've got chaff carts, which were common once upon a time, capturing everything out of the back of the harvester. Machines like a seed terminator, which the fines that are normally thrown out, which contains a lot of ryegrass, are put through a very robust mill operating at 2,700 revs per minute, knocking the seed, killing it before it comes out the back. Windrow burning, because sometimes our stubble load is not high enough, so if we concentrate the stubble into rows and burn the stubbles, then we can get a hotter burn and not burn the entire field. Chaff lines and grazing as well, and herbicide resistance testing. So we have organisations like Weedsmart, which do a lot of publicity with giving us the main techniques to reduce seed, rotating crops and pastures. You guys do that. Some of you have a very good rotation, which allows you to incorporate a lot of strategy in there. Optimizing spray efficacy, so that is really important. Make sure that the herbicide is hitting the target. If the target is a seed or whether it's a plant. Mixing and rotating herbicides, we've talked about that. Stopping weed seed set, crop competition. So if you've got gaps in the seeding process because of a blockage, you've probably noticed that wherever there's a blockage, the ryegrass tends to have 1,000 tillers a plant, doesn't it? They're much, much bigger than ryegrass germinating in between a crop where it's outcompeted and only has a few tillers. Harvest weed set control and testing. So let's look at a little bit at what I mean by testing. So here's a situation here. Canola crop, ryegrass, heavy population, clethodim's been applied. It's done a fantastic job. But the agronomists are monitoring because if there's any survivors in there, I would want to manage to kill them. Don't let them set seed because they'll probably be resistant to clethodim. So in canola, we can do things like spray glyphosate at a certain stage. Once the canola has started to mature, and sterilize the ryegrass pollen. So that's a strategy we use very often. And this is conventional canola too. It's not Roundup ready canola, it's conventional canola. So, oops, wrong one. So I'll go through what I do. So farmers register their samples on a website, and that gives me all the information, farmer name, paddock name, what herbicides they want to test. They choose those herbicides, and it's registered. We get an alert, and then the sample arrives with a number on it. Then we can trace testing. We conduct seed testing. That is the majority of that is seed that's shed at the end of the season, or whole plants, and I'll go through each of these tests. We do some other tests there that aren't relevant for here. So seed testing, plant testing. This test here takes about minimum of 8 weeks, more so 12 weeks, because the ryegrass doesn't just germinate, it's dormant. It has inbuilt dormancy to prevent it from germinating in summer, because if you get a rainfall event, all the ryegrass germinates, and then 2 days later you've got 45 degrees, it's all dead. It knows that. So it doesn't germinate till autumn, until the temperatures start to... So we have to trick this ryegrass into germinating. Sometimes it responds, sometimes it doesn't. If it doesn't, it takes us longer to test. This is an alternative test. It's a quick test. We collect plants from the field and we test that for resistance. Moving on. So we can test lots of species, so not only ryegrass, brome, wild oats, wild radish, mustards. Broadleaf weeds have to be at a young stage. Grasses can be older. Here we've got some seedlings in a paddock. We can test these from the field for resistance. This is the most common way, tillering plants. Either a herbicide's been applied and there's a survival, and the question's asked, are these resistant or not? And sometimes they're not resistant to the herbicide they were sprayed with. So then the farmer has to think about what went wrong, why didn't they die? But we can also test these plants for other herbicides as well, and that'll give us an answer for next year. So if we were thinking of using Twin-X next year and we receive these plants this year, in 4 weeks you know if these plants are controlling Twin-X, and if they are, you know next year you can start planning your strategy already. Most of the comes as seeds collected from the grower, from the agronomist. Seedlings these are wild radish seedlings. So brassica weed from the field. When they're young, they can be sent to us. Or a grain sample that's got weed seeds in it. We can sieve them out and test them as well. So there's different ways of getting a resistance test done. With the whole plant test, the quick test, these can be older plants, pre-tillering, even early tillering plants. We can test all of these. So what we do is this large plant, you wouldn't spray this one with a post-emergent herbicide. It's probably not going to work. It's too big. we'll tease these tillers apart, these shoots, trim them down so you have a little clone of 2 tillers, little root, plant them into pots, allow them to regrow for a week. You have young fresh leaves, young fresh roots, then spray them with herbicide and you get an answer. These little ones, we'll just trim them and plant them like that, and these 2, we'll just split them a couple of times and plant a clone in each different pot. So as long as the plants are still green, the test will work. And the results, with the results, and I'll show you an example next, we provide a % survival and we provide a resistance rating. And the rating is an indicator of those surviving plants, how healthy were they to the herbicide. So where we have a R rating, that's where the herbicide has had very little effect. R rating, most of the sprayed leaves have survived, but the plant's been significantly stunted. Single R rating is where there's been a complete burn down and then recovery. That's weak resistance and susceptible. So these guys here, the weak plants, they're allowed to grow, cross-pollinate, and stack that resistance. They can go from here to here in a short number of years. The resistance usually starts here, and when it's really strong, it means there's been a lot of survival over the years, and it's moved to this form here. So here are 2 different tables of part of a report. So this is report number 1. So to test 5 herbicides cost this grower $520. He knows now that this is Twin-X. The sample he sent me, 100% of those plants were resistant, and R rating, meaning the herbicide had no effect. Another herbicide similar to Twin-X, exactly the same. Clethodim, 15% survival, so quite a bit of damage, only 15% survived, and the plants were quite stunted. This is a group 2 herbicide, similar family to Ryegrass, 75% survival, R rating, so the plants were virtually unaffected by the herbicide. And glyphosate, fair bit of resistance, 50% R rating, so this is very high. So that's serious. Now, how was the sample collected? Was that collected from just 5 or 6 or 10, 20 plants found in a large part of the field? Or were there lots of plants in the field and the farmer just quickly grabbed a few and sent them to me? Because if it was a second case, it means that resistance is common in most of that paddock in field. But if it's only a few plants, then it means it's had a really good control, but there's a few plants left, they need to be handled, otherwise it'll increase even further. This is another 4 herbicide test, $440. Again, Twin-X here, 60% resistance, being at 60. Clethodim, no, 0, so complete control, so fully effective. Treflan, 95% resistance, so high levels of resistance to Treflan. And glyphosate, just a little bit creeping in. So alarm bells ring because we don't want that to increase further. So for, between $400 to $500, these growers know which herbicides to avoid, which herbicides work, and they're going to avoid contamination, yield increases, and really optimizing the rotation for the next few years. This is from an area close to Adelaide, the lower north and the York Peninsula. So that's a very important cropping region. And out of 90 samples in 2022 season, we identified 86% of those samples are resistant to Treflan 1.5, 70% resistant to Treflan 3 litres. So the pre-em herbicide is not very effective. Treflan plus Avidex, 14%. So mixing Avidex, we find, works really well. Avidex 1.6, which is a low rate, but remember, we're actually applying the herbicide right on the seed. So very active. We 20%. Boxer Gold here, 9% of those 90 samples. Sakura 3 and some of our other pre-emergent herbicides. This one is Curb, 0% resistance, so they were effective. So we're using, these Overwatch and Ultra and UltraMAX and Matino, using it successfully in the rotation with cereals and broadleaf crops to keep those numbers at bay. Okay, I'll move to grazing. We were talking yesterday about grazing, looking at all these beautiful cows and sheep, happy in the New Zealand countryside. So I thought I'd just do a little bit of a search, because we discussed, okay, they eat straw, weed seeds. What pops out the back? Are they alive? Are they dead? What control of those dry seed happens? So there's been a couple, or at least a couple papers written. This was one from in Australia, but we found another one from the UK which had virtually the same percentages. So they found annual ryegrass seed in the cattle and sheep that went right through the rumen. 10.8 to 11% that went through a cow was still germinating happily, and a third through sheep. So don't think that if you're feeding your sheep ryegrass, some of it's going to be alive when it comes out the back end. So just be aware of that. Okay, time for a drink. Nothing like a good New Zealand Pinot to lubricate the mouth. Right, so we've talked about ryegrass, but why is it such a resistant weed? Why is it such a problem weed? And it has some very unique features to virtually every other weed that grows, apart from wild radish, and that is our second biggest problem in arable cropping. So ryegrass is genetically really diverse. It's got a lot of different genetics with lots of features. In the 1990s, we used lower rates of herbicides because herbicides were really expensive. And any of you that bought herbicides in the 80s would know that from today's prices, it was probably costing you $500 for a 20-litre drum, and today it's costing $120, $130. So lower rates were used. The ryegrass, its genetic diversity also includes resistance mechanisms by chance and different ones. So if you're using lower rates for decades and you've got a lot of genetic diversity, then you're going to be able to start fishing out those weak resistance mechanisms and accumulating them. Its super feature is that it's an obligate outcrosser. And what that means is that it must self-pollinate to produce fertile seeds. So if you bring a pot in here with one flowering ryegrass plant, it will not produce any seed. If you bring a second plant flowering, one is resistant, one is susceptible, you put them in close proximity, they cross-pollinate, the seed from the resistant mother plant will all be resistant, the seed from all the susceptible plant will all be resistant, because all of the resistance has moved from the resistant mother plant. So that's how it spreads really easily. How far does pollen move? We've actually documented to move 4 kilometres, okay, and remain viable. Fertilised seed, 4 kilometres. So that's, but in reality what happens is its neighbours cross-pollinate amongst themselves because there's trillions of pollen grains. So a chance of a pollen grain coming from a kilometre away, fighting through trillions and trillions of pollen grains, fertilize a plant is almost impossible, but it can happen. But if you've got a situation where you've got a wheat crop and it's got, Twin X resistant ryegrass in it, and right next door there's a seed crop, ryegrass seed crop, and there's wind moving and stuff, then some of that resistant pollen is going to move into that seed crop if its flowering times are aligned. So the one's closer to the border of both of those. So it's something to, just keep an eye out. Resistant survivors cross-pollinate, and if there's different mechanisms, they just stack. Bang, 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 and then you got resistance to completely different herbicides that you didn't expect. And here is an example of one, and this is where we've taken a ryegrass with one specific mechanism and crossed it with a ryegrass with another different mechanism together, formed a hybrid, and then conducted a spray trial with all of those parent lines and the hybrid and the susceptible to see, how do they respond to glyphosate. So we have survival percentage, we have increasing rate of glyphosate. We have our susceptible ryegrass, which is killed at rates below the field rate. We have our ryegrass mother plant with a target site resistance to glyphosate, another mother plant with a translocation mechanism, and the hybrid has both in it. And it's significantly more resistant to glyphosate than either of the parents. When we took leaf material back to the lab and tested the DNA, we were able to identify both of those mechanisms in the same plant, so they'd hybridized. And that's how resistance increases, the level increases in the field. It doesn't happen at one time. I go to Australian farmers, you guys have worked really hard to create these monsters. You've done a great job of increasing it. It didn't happen in a year. Resistance to 5, 6, 7 litres of glyphosate didn't happen in a year. It took 30 years. To give you a very brief understanding on the different ways that ryegrass has evolved resistance, this is to glyphosate, but also to other herbicides. So what happens, you spray a herbicide, it's absorbed by the leaves, goes down to the growing point, inhibits important enzymes, plant starves to death, dies. The most common mechanism for glyphosate resistance in ryegrass is what we call a sequestration mechanism. So the glyphosate's absorbed, but it's actively pumped, kept away from this region here, the growing points, to the leaf tips, and the leaf tips burn off and the plant recovers. The other mechanism is target site, and that is where you have so glyphosate kills one enzyme in the plant called EPSP synthase, and this whole massive enzyme, there's a binding site where reagents form in there, they create other reagents, and the plant functions and produces 3 key branched amino acids, which is essential for life. What glyphosate does is it actually goes in there, finds this target site, binds, sticks in there, it doesn't come out. So this enzyme can't work anymore, and the plant starves to death. That's target site resistance. Target site, that's how it kills. Where you have target site resistance is where there's a physical change. So like you get a key, but you change the lock, the key won't unlock it. Similar here, physical change, glyphosate doesn't recognise where it has to bind, floats around, enzyme keeps on working, the plant is resistant. This mechanism is the same for your group 1 herbicides such as Twinax, although it's a different enzyme, and also for your group 2 herbicide resistance such as SR, but again it's a different enzyme, but exactly the same principle. In group 1 and group 2 herbicides, this target site resistance gives you very strong resistance. Glyphosate gives you very weak resistance. We don't know why, but that's just what we've identified. This one is a really nifty new mechanisms that we identified as well. And this is where you've got a susceptible target site, so the herbicide's absorbed, goes down, starts killing that EPSP synthase enzyme, but there's so much more of it, it's 50 times more actually, that there's plenty left over for the plant to keep on growing, and so happy days. As you apply more and more glyphosate, you start to kill more and more of this enzyme, and you start to see some increased damage. So these are the ways that ryegrass has evolved, sneaky ways of avoiding dying with glyphosate. So we've done a lot of studies with some of these, and we've kind of got a rule of thumb of how many applications you need to develop resistance in ryegrass. So for fops such as purmain wild oats, or more so Twinax in ryegrass, between 6 to 8 years. So if you apply 6 to 8 years of continuous Group 1 herbicide on ryegrass, you spray, some might survive, you do the same next year and the year after and the year after, in about 5 to 6 years, you'll start seeing some resistance. And the reason is because the naturally resistant individuals are quite frequent in any population. There are about 1 in 500,000 plants. The Group 2 herbicides such as Sakura, even more common. 4 years in a row and we've seen resistance because it's a lot more frequent. 1 in 20,000 plants we've identified in some populations as being resistant. So you can have 20,000 plants in this area here, one can be resistant, easy. So it's very common. These other modes of action, glyphosate, paraquat, treflan, much more rare, and so it's taken a lot longer to get resistance to these. So if you're in a field with, this is very good control, let's go through a simple mathematical equation here. So let's pick the Group 2 frequency from before. We've got 1 resistant in 20,000 plants. If there's only 1 plant per square metre, in this field, you'll have 200,000 plants total. Of those, 10 will be resistant. If you've got 10 plants per square metre, 2 million in the paddock, 100% will be resistant. You can see the more density you have, the more plants you have, the greater the chance of having more resistant individuals. So where we are layering the sequences, we're using a pre-emergent herbicide to kill most of the plants, then an early post-emergent, then another in-crop herbicide. What we're trying to do is to expose as few plants as possible to these high-risk herbicides and avoid resistance developing. Okay, I've got a few words to say about glyphosate. Registered in Australia in the 1970s, probably similarly here. Took many years for us to identify the first case of glyphosate resistance, and that was in an orchard. A repeated use, probably, 20, 30 times, multiple times a year. In our recent random weed survey, 16% of the ryegrass in arable cropping was glyphosate resistant. That is scary high. Currently, we've got 18 species with thousands of actual paddock samples resistant, field samples. In New Zealand, 2012, you identified it. It was identified in Italian perennial ryegrass from orchards and vineyards. And now there are isolated cases of glyphosate resistance confirmed in arable cropping, and I showed you 2 of those earlier in this presentation. So it's there, but it's there in very, very low proportions. We've identified some ways to improve the activity of glyphosate on ryegrass. So if you improve the activity, then you kill any plants that have weak resistance and slow down the onset of it developing. Number 1, use good quality glyphosate products. In Australia, I don't know about here, but in Australia, we have 600 registered glyphosate products. Now, you can't go into a store and pick 600 out of 600, but there are 600. Some of those have been imported directly by farmers from China, from India, but there's a lot there. And they're not all the same. You could be applying the same amount of glyphosate, but the activity is significantly different between products. One of the main reasons is the inbuilt surfactant package that's in with the glyphosate, and that differs. The cheaper the glyphosate, the cheaper it is. They're cutting corners, and so you might be applying 2 litres. Applying 2 litres of a cheaper glyphosate and 2 litres of, say, Crucial or Roundup UltraMAX is a big difference in activity. Using good quality water, and your water here looks good quality. It's beautiful. I mean, I love drinking it, but some of that water might have a lot of calcium and magnesium ions in it. If it's hard water, it will start binding to glyphosate. Glyphosate is a weak acid. It has a negative charge. And all I remember from basic chemistry, if you've got positive charge a negative charge, they bind together, they form a salt, and you've lost activity. And that's what happens if your water is hard. So we use a soluble ammonium sulfate, either a granular or a liquid form, and one of the functions is it conditions the water. So the ammonium sulfate binds to positive charged hard ions, forms a salt, leaves the glyphosate free, do its job. If you're mixing too many in the same tank, they can sometimes antagonize. They don't like to be in close proximity. We find that younger plants are much more sensitive. So you can have glyphosate-resistant ryegrass. If you're spraying it at the 2-leaf stage, unless it's got really strong resistance, which is unlikely in the beginning, you'll kill it. But once that starts to tiller, then the resistance mechanism is expressed and those plants will survive. So resistance is not the same throughout the whole life cycle of the plant. Glyphosate works much better under cool, cold conditions, and that favours you guys. Cool, cold conditions. Outside today, beautiful. Cold, nice and cold, works much better. You spray it in the summer, it just doesn't work. What about, sorry? Yep, that's fine. It absorbs better during the day because it's actively absorbed. So when the plant's in the evening, night, it locks down a little bit. So there's less uptake. It still works. A lot of farmers will spray at night because of that, but it's a little bit less effective. But it's still okay. Our guys stop using it more so for drift because we get a lot of inversion layers. So it sort of wafts, and then it moves and creates off-target damage. We're applying a lot of our glyphosate in summer to kill weeds in fields, and we're scared of it moving into vineyards and towns and other places like that. So whereas here you don't do a lot of summer spraying because you harvest your crop and basically 2 weeks later you're sowing your next crop. So it's very different. We have a 3-month fallow period. Warm. Above about 25, you start to lose pretty important efficacy. It's the drying factor. If it's humid, it's okay. So in the tropics, glyphosate works beautifully. It could be 30 degrees. If you've got 90% humidity, that glyphosate will stay on that leaf for a long time and it'll all absorb. But if it's drying quickly, in our summers, they're dry. It dries real quick, you lose it, and it doesn't, even if it rains or you get dew, it doesn't rehydrate. So it's actually the relationship between the temperature and the humidity. And when it's generally fast, when it's hot, it's dry. Cool, cold, frost, 1 degree, 2 degrees, it's fine. It'll absorb. No problems at all. Even in frosty conditions. Oops, wrong one. So let me talk about glyphosate formulations or glyphosate products. So this is an example how it differs. So we've got, this is glyphosate resistant ryegrass, but only weak resistance. Susceptible ryegrass. Each line are 3 replicate pots of a formulation. So this one is Roundup UltraMAX, those 3 pots. On the resistant, you see we've got dead, some surviving, and on the susceptible Roundup UltraMAX, dead. Here's another product. We've got a few more survivors, similar here, and this one's pretty crap. On susceptible, this one's really effective, and so was this one. But yeah, so you can see, same. We adjusted everything, so we're putting out 500 grams active of product, and we are getting significant differences. Difference being the adjuvant package inbuilt. This is one of our first ryegrasses. This is some old data. We have our 540, inbuilt 540. At high rates, it controls, 100% control, but at field rates, Roundup UltraMAX is giving us almost 100% control. The other product is giving us 20% less control. So that is significant. That's the difference between leaving plants behind, healthy that'll recover and accumulate those resistance mechanisms, and up here we're killing them and we're not. So we're stopping resistance versus making it start. Ammonium sulfate. So it conditions water, like I mentioned, but it also has at least one other function. And to show it, here we've got some pots that was sprayed with glyphosate using soft water. So soft water, no cations, no calcium and magnesium ions. Hard water, 312 parts per million. Not very hard, but harder than the soft water. So 2 waters, glyphosate alone, glyphosate plus 2% ammonium sulfate, glyphosate plus increasing the wetter concentration. So you can see adding the ammonium sulfate or more wetter, we got increased control versus just the glyphosate. And this is a 540, so it already has an inbuilt surfactant, but the ammonium sulfate gave it extra activity. This here costs about 5 cents a hectare, I think. It's tiny, it's so cheap. It's an insignificant cost. But it's not only used with glyphosate, it's used with virtually every herbicide. In the tank, let it agitate for 5 minutes, let it do its magic with the water conditioning, but then it's also helping use with clethodim, use with other products as well. And yes, another example, glyphosate plus AMS on the same population, so quite improved control. Okay, FOPs versus DENs. So basically Galant herbicides versus your Twinax herbicides versus clethodim there. So how do they're all group 1, they all inhibit the enzyme ACCase. They all bind in the same site, but they bind slightly differently, and that's why you get differences between them sometimes. Let's have a look at the differences. So I test a lot of ryegrass. I've been testing it for 20 years. I've got a database since the last 10 years is in one site. So I was able to extract 350 farmer paddock field information where they tested clethodim versus Galant. So how do those two compare? It's resistant to one, what's the other one? In 61% of cases, clethodim was 100% effective on Galant-resistant ryegrass. Okay, so you got group 1 resistance to the FOPs, but clethodim worked in over half of the cases. So that is an important bit of information to know for a particular field. What about Galant versus Twinax, those two? Here I've got 162 field samples where both were tested at the same time. In virtually every case, ryegrass resistant to Galant was resistant to Twinax. So even if you've never used Twinax and you've got confirmed resistant to Galant, the chances are this herbicide is not going to work either. There might be the odd case it will, but chances are, that's a big data set that it isn't. So that's very important. So getting the most out of the dim herbicides. Dims are clethodim. First of all, field failures are not always due to resistance, and we see this a lot with clethodim. We also find that with glyphosate also. Often it's resistant, suspect, but we find it susceptible. Spraying younger plants, also important. In the early days, growers let everything grow nice and green, make sure we don't miss any subsequent germinations. Little plants, big plants, shading, apply glyphosate, apply clethodim, and you get a dog's breakfast because you get shading, plants survive, and they cause issues. Spraying earlier, spray younger weeds. Warmer conditions. So unlike glyphosate that likes cold conditions, clethodim hates cold conditions, loves warm to hot conditions. So it's exact opposite. If you've got frost or cold, clethodim won't work as effectively as if it's warmer. So, and it's not like above this temperature, below this temperature. It's just a continuous scale. You get better coverage if they're younger as well. And another thing is, I don't know what MSO or oils you use with clethodim, but we found in Australia that that Haston from Vic Chemicals is, from what we've tested, the best adjuvant for clethodim. There might be some better ones, I don't know. I haven't tested all 300 of them, but of the 20 that we've tested, consistently, Haston at 1% is the best MSO for clethodim. And yeah, if the ryegrass is stressed, water logging, cold, then yeah, you're going to get less uptake. We're getting pretty close here. Here's a photo. Here's a trial I did. This is a few pots from a very complex trial I did. I grew hundreds of pots of ryegrass with resistance to clethodim, weak resistance, not strong resistance. So group A, this is the old lettering, it's actually group 1 now resistant. So hundreds of pots in winter, and I waited for a frost. So frost was coming, like a big frost. I took a third of those pots, transported them to a place in the Adelaide Hills, had 3 days of -3, brought those plants back, sprayed all of the pots with clethodim at 500 mils per hectare of the registered rate, plus 1% Haston. Then I took a third of the pots that hadn't been exposed to frost to the frosty area, copped a bit more frost for a few days, brought them back. So we had a third of the plants sprayed before the frost, a third of the plants sprayed after the frost, and a third of the plants left at our station in Adelaide, still all outdoors in winter, not in a glass house or anything like that. Waited for the symptoms to develop and clearly identified that the plants that were sprayed after the frost had significant survival versus the plants sprayed before the frost died or had very weak resistance. And the reason is that the frost hardens the plants, and so when you're exposed to clethodim afterwards, then it doesn't work as well. And plants can respond quite quickly. So you have a frost period, and then the temperatures, cloudy conditions, you get the teens rather than the below zeros. That'll recover 2 days later. You can wait, you can spray, and then you'll get better results than you would if you'd sprayed 3 days before. So just to summarise, we're mixing, we're rotating post-emergent, pre-emergent herbicides. We're trying to confuse the out of ryegrass, okay? We're trying to do different things and so it doesn't get used to any one strategy. That's the key. Using, maintaining top label rates, using good quality products, using herbicides under good conditions where possible, incorporating non-herbicide techniques to reduce herbicide resistance. And the other thing that is different to here is we test for herbicide resistance to try and optimise the programs for the future. So you might have to bleep out that word. You can't have those words during if you're showing this presentation to kids, you can't have those words. So I'll leave it there, and yeah, please address any questions. Thank you.